one second. 66 million years ago, Earth got hit by a 10-kilometer-wide asteroid traveling at an insane 64,000 kilometers per hour. I mean, the impact was a billion times more powerful than the Hiroshima bomb. We went from a totally thriving planet to a brutal impact winter that literally killed 75% of all species. But some survived. And those tiny survivors eventually evolved to build spacecraft capable of stopping the exact same type of asteroid. This is the incredible story of how close we came to never existing at all and how we're now actively working to make sure it never, ever happens again. Let's get into it.
First, let's really try to understand the sheer scale of what actually happened that day. When an object that massive hits Earth at 64,000 kilometers per hour, the kinetic energy released is almost impossible for us to even comprehend. We are talking about an explosion equivalent to billions of nuclear bombs going off simultaneously. It was so violent that some scientists actually believe the collision threw pieces of the Earth's crust so high into the atmosphere they completely escaped our gravity and hit the moon. No way, right? But the physics actually support it.
Okay, let's dive into this. Scientists call it the Chicxulub impact. This monster of an asteroid slammed into what is now the Yucatan Peninsula in modern-day Mexico, and it left behind a crater that's over 150 kilometers wide. That alone tells you the unimaginable scale of the destruction we're talking about here. The initial shockwave completely leveled everything for thousands of kilometers in every single direction. Within minutes, earthquakes far more powerful than anything in recorded human history just rippled across the entire globe. And then there was the debris. Millions of tons of shattered earth blasted upward, creating this deadly canopy over the whole planet.
Now, what's really terrifying is the sheer speed of how fast everything went down. At minute 0, you've got the massive impact and shockwaves, right? But by minute 40, molten rock starts raining back down from the sky. The dinosaurs never even had a chance to understand what was happening. Think about it, the dinosaurs on the exact opposite side of the planet had absolutely no idea their world was ending. One moment everything was perfectly normal, the next moment their doom just rained down upon them.
And it gets worse. As all that ejected debris re-entered the atmosphere, the friction generated immense heat. I mean, the atmospheric temperature rapidly spiked to an absolutely unlivable 1,500 degrees Celsius. It was simply too hot to survive.
Scientists actually described the sky on that day as essentially an oven. The infrared radiation from millions of tons of molten rock falling back through the atmosphere acted like a giant global broiler. It instantly ignited colossal forest fires all over the world. Honestly, anything exposed on the surface of the Earth was quite literally cooked within hours.
And then came this second wave of destruction, which was arguably even more devastating than the initial fiery impact. Massive clouds of vaporized sulfur dioxide and dust particles were thrown so high into the atmosphere, creating this super thick global cloud cover. And that blocked out the sunlight completely for an estimated 1 to 2 years. Without sunlight, the dominoes fell really fast. Photosynthesis collapsed, the plants died. With no plants, the herbivores starved to death. And once the herbivores were gone, the massive carnivores lost their only food source. It was a total, unavoidable collapse of the entire global food chain.
And this brilliantly illustrates the horrific toll of that impact winter. Fully 75% of all species on Earth were wiped out. That 75% includes every single non-avian dinosaur species. Think about that for a second. These majestic, massive creatures had dominated the planet for over 150 million years, and in a geological blink of an eye, their reign was entirely extinguished. But right in the middle of this awful mass extinction, the story takes a really remarkable turn. While the massive dinosaurs, who obviously required abundant food and lived totally exposed on the surface, were doomed, a different kind of life found a way. Small mammals, many of them no bigger than rats, managed to survive. Their small size meant they just needed less food. Their less specialized diets allowed them to scavenge whatever was left. And most importantly, their ability to burrow deep underground gave them a profound survival advantage against both the blazing surface heat and the freezing dark of the impact winter. When the skies finally cleared, those tiny rat-sized survivors emerged into a completely changed world. They filled the massive ecological void left behind by the dinosaurs. Over the next 66 million years, they diversified rapidly into the incredible variety of mammal species we see today. And eventually, after millions of years of evolution, that specific resilient lineage produced us. So in a very real, scientifically grounded sense, you exist today exactly because of an event that nearly ended all life on Earth. Kind of blows your mind, doesn't it?
Humanity's triumph, the DART mission.
So jumping forward to the year 2022, we are no longer passive observers waiting for the cosmos to dictate our fate. The story doesn't end in the ashes of the past. Enter DART, the Double Asteroid Redirection Test. This was humanity's very first real-world test of planetary defense technology. NASA deliberately took a spacecraft and crashed it straight into an asteroid called Dimorphos. Now, Dimorphos posed no actual threat to Earth, but it was the absolute perfect target to test kinetic impact. Basically, seeing if slamming something into a space rock could physically change its trajectory. The scientific community waited with bated breath for the results of the impact. 32 minutes. The collision altered the asteroid's orbital period by a massive 32 minutes. That result far, far exceeded what scientists had even dared to hope for. We proved that if we identify a dangerous asteroid early enough, we can physically move a celestial body right off of a collision course with Earth.
Let's move to and see how this builds modern planetary defense. Because of missions like DART, space agencies all around the world are actively working together to build our modern reality. We have continuous global asteroid tracking programs constantly scanning the skies for massive objects. The entire strategy is to identify potential threats decades in advance. That gives us the absolutely crucial time we need to launch a redirection mission, ensuring that an extinction-level surprise never sneaks up on us again.
So the crucial point is this: 66 million years ago, the dominant species on this planet were the passive victims of cosmic chance. Today we are active defenders of our home planet. The exact same Earth that once watched dinosaurs perish in a matter of hours has produced a species capable of looking up, detecting the threat, and actively building a shield. On a geological timescale, that huge leap happened in the blink of an eye.
It leaves us with a sobering reality, but also a highly empowering one. Extinction-level events are not just hypothetical. We know they happen, and the cosmic math tells us they will happen again at some point in Earth's future. The threat of space rocks is very real, but based on what we've already achieved with DART, the answer to whether we will be ready is increasingly and resoundingly yes. We literally built the technology to stop the exact type of event that once nearly wiped us out.
I want to leave you with this lingering thought to ponder. Does it change how you see our place on this planet, knowing that our entire human existence traces back to a random asteroid impact, knowing how close we came to never existing at all and how hard we're fighting to stick around? Let me know your thoughts down in the comments. I absolutely love reading your perspectives. If you found this explainer fascinating, hit that like button and subscribe for more deeply researched explainers every single week. Keep learning, keep looking up, and I'll see you in the next one.